segment about sessions. Now we're going to talk about cross-site request forgery. Okay, so we've seen HTTP is stateless. We need to implement sessions. Usually that's done via a unique ID that the server knows and stores in the browser of the user. If there's no way for us to steal the session ID or to predict it somehow, what can we do as an attacker? Well, actually we're not interested in the session ID. It would be sufficient for us as an attacker if the user does something we want him to do. So how could we do that? Well, we could do something called cross-site request forgery. So imagine a script in the backend of the web server that uses session. So it has a unique session ID, so I can check variables inside this session. So in this case, it is checked if the user that is currently logged in, that possesses the session ID, is an admin. Has a role of an admin, so is privileged. And if that is true, if this user is privileged, then the function is called createUser. It's a function we implemented. This magic variable request just gets the parameters from a GET request or a POST request. So it takes the username from the HTTP request, the password and the role, and then just creates the user. Now this should be secure because the user, in order to be able to reach this code to create a user, has to be an admin. Session store has to say that this particular logged in user is an admin. Well, what we can do as an attacker now is we can employ an attack called cross-site request forgery, or CSRF for short. It works relatively simple. So we have a user we want to attack. In this case, this user is an admin on our website. So the user logs in on his own website and is an admin at victim.com, for example. What we do next as an attacker is we somehow lure this user into visiting a website that's controlled by us. So let's say we send this user an email saying, oh, look at those cute cat pictures on this website. The user visits our website. We control attacker.com. And the website actually has cute cat pictures, but it also has an image in HTML code that actually fetches its image or its content from the victim website where the user is logged in as admin. And the image URL is create.php something something. And now if you imagine this script here is the create.php script, what we would do is we would create an image tag that has this URL with something that we control. So what happens now is that the browser of the user issues an HTTP request to this URL, which it's what it's supposed to be doing because the website tells him that that's an image. But the browser has a cookie for this website that identifies the user as admin with the session ID inside. So the browser willingly issues a request to the victim website with all credentials with the session ID and therefore creates a username that we as an attacker control because we set this image tag on our website. So now there's a user created on the victim website without the administrator noticing at all. As a cross-site request forgery. Afterwards we can log in with the user that was created, which is bad. So does this happen in reality? Yes, unfortunately it has happened a lot, especially in the past. CSRF attacks were successfully used, for example, against Gmail. For a while you could steal the address book of a Gmail user via CSRF. You could steal Skype credits, and you could, as I remember, see what user on Netflix has watched. So stealing Skype credits and stealing the Gmail address book is obviously pretty bad for the end user. And you can see that this type of attack is sometimes difficult to mitigate because these companies try to do their best in security, and even they were vulnerable. What might also be interesting, it has been used in the past to reconfigure routers. How was that done? Well, fairly simple. You would send an email to a victim, and some mail programs, for example the Apple one, just download images. So if you send somebody an HTML email with images inside, the mail client just happily downloads images. So what an attacker would do is he would embed an image in an email with an URL something like that: admin @. If that doesn't tell you much, this is how you can write credentials if you log in via HTTP. So this URL uses the username admin and the password admin for the typical IP address of a home router. These are standard credentials. So we assume that this router has standard credentials of admin, has this IP address by standard, and has an HTTP endpoint where you can set, the DNS server. So with this image embedded in the email, the DNS server of the router is set to the IP address 5432. Why is that a problem? Well, this is your home router, and it's your default gateway, and it's your DNS resolver. So if you want to visit a website in your home network, what your computer does is it asks your home router, hey, I want to visit this banking website, please give me the IP address. And the router does so by contacting a DNS server, most likely of your ISP, of your internet provider, and then it tells your computer, okay, the IP address for your banking website is this and that. And obviously an attacker here would set a DNS server that is under his control. So every time you want to visit a website, for example your banking website, the DNS server of the attacker would always return the IP address of an attacker server. And then instead of the website of your banking provider, you would end up on the website of the attacker. This is a kind of attack that is very difficult for an end user to realize, because the browser bar still says bankingwebsite.com, just the IP address was resolved to another one. In order for this to work, an email with this kind of attack would have thousands of images embedded with different kinds of routers and different kinds of default passwords for different routers. So in order to mitigate this, it is not enough to just not do state changes via GET requests. Sometimes on the internet you read, okay, against CSRF, just don't do GET requests for changing things. But it's not enough, because on a website I can also just issue a post request via JavaScript. So the way to mitigate this is CSRF tokens, which can be a pain to implement because some languages don't support that out of the box. But that's the only way to mitigate this kind of attack.